say. We were doing communication, we were communicating with each other, but all the means of communication that used to be used that days were all non-electrical. So that is not of our concern, or we are not actually in this electronics course, we are not at all bothered with how things used to be communicated in those days. Okay. So actual telecommunication, which we talk about in electronics, electronics and communication, the actual telecommunication, it started basically in the 19th century. Okay. So sometime in 1838, as I said in the last class, the telegraphy was the first long distance message communication that started. Okay. It was invented by Samuel Morse. Okay. So that was the first telegraphy was the first telecommunication system that started sometime in the 19th century, and later on the telephony system was developed, and gradually things evolved over time. And in the last 3 decades or so, there had been a tremendous development in the communication, not only in communication, actually it is a uh, combined development of electronics, computer and communication, these three things. So basically nowadays, if you know already, you might have already observed that neither electronics alone, nor computer alone, nor communication alone, all three actually go hand in hand. And nowadays your communication is dependent on electronics, the computer is also dependent on electronics, communication is dependent on computer also, because nowadays we are doing mostly all computer based communication. So things have developed in the last 3 centuries. There had been 3 decades, the last 3 decades there had been a tremendous evolution in communication. So we'll gradually go into that. We'll gradually discuss about the things that how communication gradually developed and what is the modern day communication about. Okay. So what we were talking about in the last class is that uh, this telegraphy system, we have already discussed this, and as I said that it was there is no electronics in it. So that time there was no electronics in it, because in fact there was no electronics existing at that time. In the 19th century, there was no electronics. So everything was electrical based. So it was more of electromechanical type. Okay, and this telegraphy system, as I said, basically the transmitting end, what you have something like a switch like this. So you keep on pressing this switch here. So when you press this switch for a small duration, you make one pulse which corresponds to a dot. When you hold it for a longer duration, which is basically 3 times the duration of the dot duration. So when you hold it for a longer duration, it gives you a dash. And a combination of dots and dash that gives you the code for different uh, alphabet and numerical symbols. So A, B, C, D, and 0, 1, 2, 3, like that. All of these letters, they have some code has been assigned to each one of these letters, and you, when transmitting a message, we used to send that message corresponding to that letter. That is what how the telegraphy system used to be handled in those days. Okay, that is how you used to transmit the message. And at the receiving end, so this code, actually this telegraphic code is called Morse code. Okay, this is called Morse code after the name of the inventor of telegraphy. So it is called Morse code. Nowadays it is no more used, obviously, because as I said in the last class, that in the last decade of the previous century, uh, during the 1994, 95, there used to be, till that time, there used to be telegraphy system, but after that it has become obsolete. Okay, because once the email and all these things become more popular and more yeah, before that actually email was there, but it was not used in a commercial basis. It was not accessible to all people. So after 95, 96, around that time, it started gradually the email system and all these things became accessible to public also. So before that, it was only restricted within the organizations and educational institutions. Only there used to be email communication between companies and between academic institutions like that. But after 95, 96, around that time, it started gradually, this email system became more accessible to the public. So this telegraphy system gradually it became obsolete after that. Okay. So Morse code is no more there. It is no more used nowadays. Okay. Anyway, the telegraphy receiver was something like this, that as you switch on the receiver, a paper tape will keep on rolling down like this. Okay. And whenever you receive a dot, okay, a pulse corresponding a dot, there is an electromagnet. This electromagnet will get magnetized and this ink roller will be pulled down because of this electromagnet, and so this ink roller will be pulled down on the paper tape, so it will put one dot. Okay, it will be briefly for just that pulse duration, this ink roller will come down. So on this paper tape you will have one impression of a dot, and if some pulse, longer pulse corresponding to a dash is received here, so this electromagnet will be magnetized for a longer duration, ink roller will come down for a longer duration, which is more or less 3 times the duration of the dot, and so you will be having one dash printed on the paper tape. Okay, so this paper tape will have a series of dots and dash. Okay, as you can see here in the picture, here also I have shown that it is dash and then dots like that. Okay, so some dash and dots will be printed on the paper, and there will be some expert who will be then deciphering that dot and dash. Okay, decode it and then find out what is the message that has been transmitted from this end. Okay, so you need two experts on both the ends. One expert here to convert a message into dots and dash, and one expert here needs to convert that dots and dash into the corresponding message. Okay, so everything was manual. Okay, this decoding, all these things were manual that time. That is, nowadays it's obviously no more manual. In computer communication, the computer will do it. Okay, but that day in telegraphy system, only this part was yes. You mute your mic. Someone's mic is on. Okay, so the electrical system was only restricted within this. Okay, coding, decoding was done manually, and that time there used to be some institutions where people used to take training for doing this coding, decoding, and they used to get experts, and then those experts only used to get job in telegraphy department like that. Okay. Anyway, then we came to the telephony system. We started with the telephony system. It was invented by Alexander Graham Bell in 1876. And then telephone system, as you know, it is still existing nowadays. Okay, although it has evolved a lot. Okay, you have still the landline, which is the modern version of the telephone system that used to be existing that time. So it has evolved, and you still have the landline, and a different version of the telephony system is nowadays your mobile. Okay, so you can say telephony is not yet obsolete. Okay, although it has changed a lot. Okay, the earlier days telephone system was electromechanical type, whereas nowadays the telephonic system is completely electronic based. There is no electromechanical things nowadays. Okay, so that is a big change from electromechanical or electrical system. Now it has become completely electronic system, the telephonic system, and that is why the reason the present day communication is mostly based on electronics and computer, as I said, and that's why we study this communication as part of electronics engineering. So we are studying electronics and communication engineering because communication is nowadays mostly it is based on electronics. So if you don't study electronics, it cannot understand communication. Okay. Whereas if you study electronics only, it's okay. There are many academic institutions where they offer only electronics engineering. But again, only electronics engineering may be not enough for 4 years course. And so that maybe because of that, we have incorporated this communication along with electronics. You can say like that. It is incorporated along with electronics, with where the communication is, you can say, is one of the most important application of electronics. You can say like that. Okay. So that is actually the reason why you are studying electronics and communication engineering, why these two engineering are studied together. And in fact, nowadays, in many institutions, they have also started courses like computer and communication engineering, like that. Because now students are studying computer engineering and this communication as one application of computer engineering also. But anyway, that is all not very popular nowadays, computer and communication engineering. So it's mostly it is electronics and communication engineering, which is being studied in most of the institutions nowadays, not only in India but worldwide. Okay. Anyway, so the telephonic system, which I was discussing about in the last class, that you have one handset, okay, and whenever you want to speak to someone, you have to lift the handset. And this handset is basically having two parts. You have a microphone, okay, that is the mouthpiece. We generally say that this is the mouthpiece and this is the earpiece, okay, where you have the speaker. You whatever the message is received, whatever the sound is received, that is played in this receiver, and whatever you talk, that goes in this mic. Okay, this is basically the handset. It looks like this. Okay, whenever you pick up the handset, okay, in the earlier systems, nowadays it's mostly electronic inside, but in those systems there used to be a string like here in the earlier telephone set. There used to be a string like uh, mechanism here, that whenever you lift this handset, this will get connected. This switch will get connected. Okay, and whenever it gets connected, that means now your telephone set is getting connected to the outside world. So this is the line to the outside world. Okay, so when this handset is put down, then this switch is off. Okay, this is disconnected. So you are disconnected from the outside world. But if someone gives you a call at that time, then the ringer is here. Ringer is connected. Ringer is not disconnected. So the ringer will ring. So you know that someone is calling you, and then you lift this handset, and whenever you lift up this handset, then you get connected to the outside one. Okay. So this is how the handset is generally used for controlling, yeah, whether you are connected to the line or not. Okay. So that is the basic structure. So this is how the dialing, I think this is the slide which I was discussing in the last class. So this is the dialing that used to be used in those old days. And in fact, not only old days, it was still there till the last decade of the previous century. Okay, in fact, I have seen it, I have used it. Okay, nowadays you don't see this anymore. Nowadays it's tone dialing. You just press the button. Okay, so that is tone dialing. I'll just show you afterwards that how tone dialing things work. But the earlier days dialing was something like this. You have a rotary switch, rotary. This is the dial. Okay, so you just put your finger in one of this digit corresponding to the telephone number, and then you bring it, you rotate it in the clockwise direction till this finger stop, and then release it. When you release it, okay, see, whenever you lift the handset, you are getting connected to the outside world. So whenever you are getting connected, then a continuous current will flow in the line. A continuous current will flow in the line. But when you dial it, then as this this dial, this rotary dial, when it goes back, means you pull it in the clockwise direction, you pull it till this finger stop and then release it. When you release it, it will go back in the anti-clockwise direction. It will rotate it back. It will rotate back to its original position in the anti-clockwise direction. And when it rotates back, there is a mechanism that it will cut the electrical line that many times as you have dialed. Means if you are dialing, if you have dialed 4, number 4, the mechanism is such that it will cut the electrical line 4 times. So 4 pulses, you can say the pulses actually, you have continuous current, but the pulses will be cutting the line. So I'll just show you how this is how it happens. So whenever you are off hook, you have continuously the current is flowing. Now when you are dialing 3, the line will be disconnected for 3 times. So it is actually the pulse in the opposite polarity. Okay, so you have 3 times, it will become 0 in between. Okay, so it will be 0. This is the dialing of 3. Then you pull, suppose you are dialing 3, 1, 2, then the time that is required for pulling that 1, so that is the interdigit pause. There will be the current flowing for some time. That is the interdigit pause. Okay. Then you dial 1. Okay. So again, their line will be disconnected for 1 pulse. Again, there is interdigit pause because obviously it is mechanically you are doing it. It means manually you are doing it. So obviously there will be a long gap between dial 1, dial 3 and dial 1. Then between 1 and 2, there will be a long gap. Okay, and then when you release after pulling it from 2 to that finger, this finger stop, you pull it and then release it. Then since you have dialed 2, there will be 2 times it will be cut. So like that. Okay, so pulses are produced, but pulses are in the opposite polarity. Okay, so this is how the pulses are produced when you are dialing it. Okay, now this is something, it happens in the exchange, telephone exchange. Telephone exchange, you are connected basically to the telephone exchange directly. And the telephone exchange will connect you to the called person. Okay, it will connect you to the called person. Now for simplicity, just assume that there are 10 people. There are 10 people in the locality and each people is having a single digit phone number, 0, 1, 2, 3, like that. So maximum 10 people are there. Okay. Now suppose you are calling a person whose phone number is 4. Okay. So you have dialed 4 here. So 4 pulses will be produced. Those 4 pulses will be coming here. Okay. Now this electromagnet, according to that 4 pulses, the polarity will be reversed because as I have shown that the polarity there is in the reverse direction. Then there is a mechanism that you reverse the polarity and accordingly the electromagnet actually work like that. Okay, that when 3 pulses are coming, okay, this electromagnet will be energized 3 times for 3 pulse duration. 3 times it will get energized and in between again it will be releasing. So the armature, you can see the armature will be pulled. This armature will be pulled down 3 times. If I am trying, sorry, I have said that the phone number is 4. The called person phone number is 4. So you will be having 4 pulses and this armature will be accordingly pulled 4 times. It will be pulled 4 times and in between there will be a gap between the 4 pulses. So it will be pulled once, released for briefly for some time, then again pulled once, like that 4 times it will be pulled. Okay. Whenever this armature is coming down, you can see that there is a this ratchet wheel. This is called the ratchet wheel. This hook, this pawl, it is called pawl. This pawl is actually holding this ratchet wheel from moving. Okay, it will hold it. It will not allow the ratchet wheel to move at all. Otherwise, if there is no pawl, because of the spring, this ratchet wheel actually will be, otherwise it will keep on rotating. Okay, it will keep on rotating for means this spring actually will be pulling it. Okay, the spring actually will pull it and hence this ratchet wheel will rotate. Okay, it will rotate in the anti-clockwise direction. Now whenever the first pulse comes, then this armature will be pulled down, the pole will be pulled down, and hence it will get the contact from the pole and the ratchet wheel that will be disconnected. Okay, so the pole will be moving a bit slightly. It will get disconnected from the ratchet wheel. So the ratchet wheel will, because of the spring, the ratchet wheel will start moving in the anti-clockwise direction. But the pulse width is such that it can move only, it can rotate only for a certain time till this wiper, the wiper moves from one contact to the next contact. Okay, it moves from one contact to the next contact. By the time it moves from one contact to the next contact, the pulse here, the pulse coming here, that will be stopped. This armature will go back and the pole will now again come back to its position and hold the ratchet wheel from moving any further. So basically for one pulse, the wiper moves by one position. So if there are 4 pulses, this wiper will move by 4 positions. Okay, and then you have that this contacts are actually connected to the to all the subscribers. These contacts are connected to the subscribers. So when you are getting connected to the after 4 pulses, it gets connected to the one which is corresponding to the 4th subscriber, which is the called person. You have called the 4th subscriber with number 4. So basically this is how the rotary switch works in the telephone exchange, giving you the connection to the subscriber that you are calling. The subscriber here you are calling the subscriber number 4 and you get connected to subscriber number 4 line. Okay, this is how the dialing used to work in those days. Okay, now I said that I have taken a simple case in the previous one where I have only 10 people in the area. Okay, so there are 10 subscribers. So the exchange is basically making connection between one person to the other within those 10 people only. But you know that we have to make a call from one locality to another locality, then from one city to another city, or even from one country to another country. Okay, that is how we generally make call. And the dialed numbers are more and more. Means suppose there are 100 subscribers, then there will be 2 numbers. You will be having 2 numbers, 00 to 99. Okay, if there are 1000 subscribers, then obviously you have to have minimum 3 numbers corresponding to the subscriber. Okay, now how you make a call when you have multiple numbers? Okay, now if you have 2 numbers, so first take 2 numbers. When you dial the first number, then in the exchange actually you have something like this. Okay, you have something like this. So when you dial the first number, this contact that I am showing here, it will move vertically due to some electromagnet which will be pulling it. It will get energized. Say I dial 5, the first number, I dial 5. So there is an electromagnet which will be energizing this one, this vertical shaft. This is a vertical shaft. This vertical shaft will be pulled 5 times. Okay, for 5 pulses, and every time when it is pulled, it will go up by 1 position. It will go up by vertically. It will go up by 1 position. This vertical shaft. Okay, and then when you dial the second number, then for in every stage, okay, I have 10 layers like this. In every layer, again, you can see here this picture. I have 10 layers like this, 1, 2, 3, 4, like that up to 0. Okay, 1, 2, 3, 4, 5, 6 up to 0. I have 10 layers like this. The vertical shaft will move to any of these 10 layers. So if I have dialed 5, then this vertical shaft will move to level number 5. Okay, it will move to level number 5. And then in every level, I have again 10, just the same connection that I have shown here, this same thing, this one I have in every level. Okay, I have in every level. Okay, so I have 10 such connection connecting yes, semicircular things. Okay, as you can see here, this semicircular thing. Okay, so you have 10 such contacts. Okay, here. So then when you dial the second number, then it makes a contact in that level. Okay, so that is how you make a connection for two numbers. So if there are 100 subscribers, then you can make a connection at the exchange like that. Okay, if you have more, okay, here I am showing it for 100 into 100. That means 10, yeah, 10,000. Okay. Now every contact here is actually, instead of directly connecting it to one subscriber, it is connected to another exchange, and each exchange is again having 100 subscribers. Okay, so I have 100 subscribers here per exchange. There are 100 exchanges like that, and 100 exchanges are connected to the first stage here, to every 100, one of the 100 points here. Okay, so if you are dialing four numbers, so dialing four numbers will first make a connection here. It will go to some level in the vertical direction. Then in the horizontal direction, it will make a contact. So it will basically select one of the 100 exchanges. One of the 100 exchanges it will make contact. And then in that exchange, it will make a contact to one of the 100 subscribers connected to this exchange. So that is how 10,000 subscribers can be connected to each another. Okay, that is how this is the hierarchical way of establishing a call. Okay, this is just schematically I have shown how you are doing the hierarchically, you are making a establishing a call. Okay, so this is to be, you can see that it is electromechanical type of dialing, and how you can make connection from one point to another point. Okay, so this is just I am showing it for two levels. It can be, you can keep on extending it to multiple levels, and you can do you can serve a large number of subscribers by doing this hierarchical way of connection. Okay, so this is basically, I have written the same thing. So each subscriber's telephone set is connected to local central office by a simple two-wire cable forming the loop. Okay, so that is the first layer. Then all such local central offices within a larger geographical region are further connected to each other through a toll office located centrally within that region. Okay, so there will be a central office connecting. So basically, that is how the things work. I have a central toll office. This is the central toll office, and this gets connected to the different exchanges in the geographical area. So the toll offices in turn are connected to each other through intermediate switching offices, thereby forming a hierarchical structure of internet. Okay, so I think you are getting it. Okay, now how things are transmitted, or the how, what is the how they this local loop, and how these local loops and the toll offices, all these are connected. This is what is important. Okay, so you have some twisted pair local loops, as I have written here, two-wire cables. Then here I have written there are trunk lines connecting the switching offices. One switching offices connected to another switching office. Okay, from one city to another city, from one country to another country. That is how you are connecting the toll offices. Okay, so you have to have trunks. So what are the transmission media used in telephone system in those days? Okay, let us see. Now, what are we transmitting in a telephone we are basically transmitting voice. Mostly we transmit voice. We want to speak to one another. Okay. So what is the frequency? The frequency, the audible frequency, you know, it is from 20 hertz to 20 kilohertz. That is the audible frequency. We can hear it. Okay. But human speech, okay, our voice, the maximum frequency of our voice is 3.4 kilohertz. Okay. So the telephone lines were supposed to handle 3.4 kilohertz maximum frequency. Okay. Beyond this, okay, if your cable is able to accommodate more frequency, then you can transmit some other higher frequency components like music and all these things. Okay, but in the earlier days, that was not important because that time the telephone was mostly developed only for speaking. So that in those days, the transmission cable that used to be used was mostly designed to handle at least up to 3.4 kilohertz. Okay. What you're transmitting, you are basically converting the sound wave. You are converting it to an electrical wave, electrical signal. Okay. And since the sound wave itself is 20 hertz to 3.4 kilohertz, the corresponding electrical signal will be also having the same frequency. Okay, it will have the same frequency. It is just how you convert the form of the waveform. Okay, sound wave, you know, it is having sound energy. It propagates through some medium. Okay, and yeah, the nature of sound wave is uh, it is different. Because here the direction of propagation of sound wave will be in the direction it's parallel to the oscillation. Okay, it will be parallel to the oscillation. You know that. Okay, whereas in electrical energy it is different. Means your direction of propagation will be perpendicular to the direction of your oscillation. Okay, that is how there is a basic difference between the sound waves and electrical waves. Okay, this you have already studied in your physics. You know, you have studied how sound waves are propagated and how electrical waves are propagated. Okay, so basically what you are doing, that your microphone is picking up your sound wave and converting it to electrical wave. And this electrical signal that has to be now transmitted over simple conductor. So it is basically a simple conductor is required over which you can transmit the signal. But the conductor that you use at your home, okay, for your wiring at your home, that cannot be used. Why? Because the frequency of the electrical signal at your home, this is only 50 hertz or 60 hertz. In some countries it is 60 hertz, in our country it is 50 hertz. So 50 hertz is the, or 50 hertz or 60 hertz is the frequency of the power line. Okay, the electrical power line that you have at home. Whereas you can see here the sound wave is up to 3.4 kilohertz. So the simple conductor, simple wiring that you use at home, that cannot be used in telephone system. But it will be using some simple conductor with higher bandwidth, which should be capable of handling higher bandwidth at least up to 3.4 kilohertz. That is it. Okay. The first type of this transmission cable which was developed or used was single wire. Okay, single wire means it is just connecting from the source to the destination, from the transmitter to the destination only by one wire, and in both ends you are grounding it. Okay, your telephone set at the transmitter is grounded, and that telephone set at the receiving end, the telephone set of the receiver, that is also grounded. So that actually ground forms the second line. Okay, the loop is completed, the electrical loop is completed through the ground. Okay, so obviously that was good in one sense, that it was quite cheap, and it was quite cheap, and it was also easy to install the things because you have to just connect with one wire. But then the main problem with that type of, this is actually what, in fact, Graham Bell also started with this. He started with this type of single wire connection. Okay, but the problem comes is that this type of single wire system is susceptible to noise, because when you are connecting from one point to another point, there will be some noise in the conductor. Okay, you know, thermal noise. When the conductor is heated up, there will be some thermal noise, there is some short noise and all these things. So whenever electron is moving through the conductor, some problem will be there. Okay, some noise will be always there. Okay, and this noise will be picked up, and whenever this noise is picked up, then your voice that will be transmitted, that gets disturbed. So the person may not be able to hear you properly. There will be a lot of humming sound in the background. Okay, and most of the time the voice used to be unclear. The person will be not able to hear it properly, and in fact, if it is at a longer distance, the noise will be cumulative over the whole transmission line, and hence the noise will be more and more as the distance is longer and longer. Okay, so single wire system was not good. So single wire system was replaced by two wire cable. So you have both positive and negative, you can say. So that is two wire system was used, two wire cable. How it helps in eliminating the channel noise is that at any point in the wire, how I get the signal. I will be getting the signal by tapping it across the two wires. Okay, the voltage difference across the two wires, the voltage difference across the two wires will give you the signal value, the signal amplitude. Okay, the signal value at that point. At that time, at that point, you get the signal value by taking the voltage difference between the two wires at any point. Okay. Now, generally, the noise in the external noise in the two wires at the same point will be generally the same, because it is coming from the transmitter by the same distance. So the noise that has accumulated in the same distance will be same. Okay, and since that both the wires are of the same nature, same conductor, so you can expect that the thermal noise and all these things which are generated in that distance, that will be also more or less same. So at that point, you can expect that the noise that has accumulated, they are same. Now the voltage difference between the two wires will cancel out the total noise in the two wires. To some extent, it will be cancelled out. Okay, and due to that, the noise in the channel that was picked up due to all these problems, external problems, that is more or less now reduced. Okay, that is how the two-wire cable was better than the single wire. Okay, that is how the two-wire cable system was better than the single wire. However, one problem was still there. Okay, it was there in single wire also, but it is in two wire also, that problem still existed, and that problem is the signal leakage problem. Signal will get weaker and weaker. So as you go further and further, the signal will become weaker and weaker, and this was mostly due to that electromagnetic radiation loss. Why is there the electromagnetic radiation loss? That is because these parallel wires, the wires, they is somewhat, they will act like antenna. You know antenna. Antenna is, you must have seen antenna used in many transmission system. Okay, you use antenna. What is antenna? Antenna is basically whenever you have two conductors, okay, just you put these two conductors in the medium, okay, and then these two conductors will be radiating some energy, okay. You have to have these two conductors, positive, negative, and they will be radiating some energy in the surrounding medium, okay. So that antenna anyway, that actually how antenna works and all these things, so you will be studying it in your third year. You will be studying it. You will be studying in details that how the dipole system, basically the two wires form a dipole. Okay, it is called dipole antenna. Okay, it forms a dipole antenna, and that dipole antenna keeps on radiating electromagnetic energy. Okay, so that you will study afterwards. So basically the two in a two-wire system, since you are having a positive and a negative one, okay, so it forms a two dipole system basically, and some electromagnetic radiation will take place, okay. Just it will act like an antenna, and some electromagnetic radiation will take place. That is the problem. In fact, with single wire also, we will be having the same problem, where it forms a monopole antenna. And again, monopole antenna also, you'll be studying it. What is a monopole antenna? So this single wire system also having the same problem. So there is some radiation loss in the twin wire system. So this radiation loss has to be now minimized. So what people then suggested? They suggested that instead of having this two-wire cable, flat two-wire cable, we will twist them. We will keep on twisting them. Now this twisting of the cable, this nullifies the radiation. How? Because when you are twisting the cable, then the same positive and negative, and more or less at the same point, they will be appearing in the opposite direction. Okay, because you can see that if I have a positive cable, positive conductor on top, and negative conductor at the bottom, then just adjacent to it, if you are twisting it, then you will be having just the opposite. The negative one will go up, and the positive conductor will come down. Now, so at the same point, more or less, you have both the positive and the negative twisted pair cable. They are more or less at the same position, and they will be nullifying, the radiation loss will be nullified by each other. Okay, so it is basically the you are doing positive negative. Okay, so you are basically changing the orientation of the antenna, you can say like that. The antenna orientation is reversed in the opposite polarity, and because of that the radiation energy which is transmitted, that gets nullified by one another. Okay, this is how the twisted pair cable more or less nullifies the radiation loss. So that was the next development in the telephone cable. Okay, and then as we have seen that you might have to connect many subscribers over the same line. See, when I was showing you the way that one caller is getting connected to the other subscriber, okay, the called person, then you are getting connected through the exchange by a single one. Now from that exchange may be required to handle many subscribers at the same time. Okay, so suppose I want to connect one city with another city. Say I want to connect Delhi with Mumbai. Okay, I want to connect a caller. A person in Delhi wants to call a person in Mumbai. Okay, so there will be a connection established from that caller in Delhi to the called person in Mumbai, and there that connection from Delhi to Mumbai will be over some pair cable. Okay, this twisted pair cable that will be connecting the Delhi exchange with the Mumbai exchange. But now again, suppose another caller in Delhi wants to call another person in Mumbai or vice versa, then I need another connection is to be established between Delhi and Mumbai parallelly at the same time. Okay. So now if there is only one pair of cable connecting Delhi and Mumbai, then I cannot handle it. So I have to have multiple lines connecting Delhi with Mumbai. So that I'm just giving an example. So this same thing has to be done between all the exchanges, even within a small locality from one part of the city to another part of the city, you have to do the same connection, because you may have at the same time many callers calling through the same exchange connecting to another exchange. Okay. So in order to take care of that, these twisted pair cables, they were bundled. Multiple pairs of twisted pair cables were bundled together. Okay, and that forms your trunk line. You have that forms your trunk line between one city to another city, from one locality to another locality, from one country to another. Now it depends how many pairs of twisted cables you have actually bundled to form this trunk line. So that's why there was a time, I think sometime before the STD and all these things came, before that, whenever we used to make a call from one city to another, we used to say that we are making a trunk call. I don't know whether you have heard this terminology. We used to call it trunk call. So we used to call it over a trunk line. And for that, you have to book it. You have to book it in advance. Okay, you have to call your local exchange. You have to say that I want to make a call to Mumbai. Okay, and then the exchange will say, okay, we'll call you back. And then suppose there are only 10 lines, 10 such twisted pair cables. There are some 10 twisted pair cables between Delhi and Mumbai. So a person in Delhi, if he wants to make call to someone in Mumbai, he or she will first book the trunk. That is called booking the trunk call. Okay, and then whenever out of these 10 lines, whenever some line is free, okay, there are only 10 lines, 10 people only, 10 pairs of people only can contact with each other over Delhi and Mumbai. Okay, so whenever one of these 10 lines is free, then you will be allotted to that trunk line. You will be given connection, and then the exchange person will call you and say that your trunk line, your booking of the trunk line has been established. It is now reserved. Now you can talk to your caller. Okay, so that is how the trunk call used to be established. You have to book it because there is a limitation. There used to be a limitation in the number of phone calls that can be established between two regions. It may be between two cities, it may be between two countries, it may be between two states, like that. Okay, so that is how the multiple pairs of twisted cables that used to be bundled together to form the trunk lines. However, crosstalk obviously will be there. Whenever you are bundling so many lines together, there will be crosstalk. Okay. Now this crosstalk, okay, needs to be obviously needs to be minimized. Okay, but that generally it used to be this defined to twisted cables that are bundled together. Generally, they used to be given different twist lengths. Okay, and it has been again calculated, and it has been found that if you have different twist lengths for different pairs of cables, then there the crosstalk is minimized. It is reduced. Okay. However, still there will be some external interference in this trunk line. Okay, then since it is a long distance, there will be high attenuation. The signal value will come down, there will be loss, and hence there will be a signal amplitude, the power will come down, so there will be attenuation. Okay, and they used to offer a very narrow transmission bandwidth. They are good for, okay, 3.4 kilohertz voice signal, it was good. But suppose I want to try also want to listen to some music from the other end, okay, or some high frequency sound, anything, okay, I cannot hear. So that was the problem. Okay. Uh, so there's this first development was this, that these twisted pair cables were made shielded and unshielded. Unshielded were the first one, and then they were made shielded to take care of some of the interference problem. Okay. So that is how the things were, this telephone cable were gradually developed. We'll continue from here in the next class. Okay, we'll go in details of the transmission system. Telephone cable, actually, the next slide is just the last one. Okay, you can see that what I have already written, that the unshielded wire, the ordinary wire, they were cheap, so easy to install, and they were mostly used only for the local telephone, because there will be some interference, there will be attenuation, but within the local telephone networks, it doesn't matter much. Shielded cables, shielded means you have to have some shielding outside the cable, so that it can take care of the external noise. Okay, so it will shield the cable from some external interference. Okay, there are two types, there are generally two levels of shielding. One shielding you do between every pair, okay, between every pair in the bundle. So this will reduce your inter-pair interference. The crosstalk between the different pairs of cables, that will be reduced by doing the shielding for every individual pair. And then the whole bundle also, you just do a shielding. That will take care of any external problem. So this was used for a longer time. This type of trunk line system, that was used for a longer time. But later on, when coaxial cable was developed, which is obviously a better way, and it offers a greater bandwidth, so that, see, this type of telephone cables, these were just simple conductor type. So they were not able to take care of high bandwidth, high frequency. But coaxial cable was a better shielding, greater bandwidth, and in fact coaxial cable is still used nowadays, because you can design coaxial cable with higher bandwidth, which can even handle the digital communication which you are doing nowadays. Okay, very high frequency communication can be done, and it is still used nowadays. Whenever there is a wired connection, see, nowadays the communication is either wireless, that is without any wiring, so either wireless, and if it is wired, then you might be having either coaxial cable, which is still used, either coaxial cable or fiber optic. So nowadays communication is having only coaxial cable or fiber optic. This is the wired connection or wireless connection. Okay. So this is how the transmission cable system actually evolved gradually. Okay, this is how the transmission system evolved gradually over time, and mostly the transmission system cable was developed in keeping in view the telephone system, because that was the ultimate communication that was required at that time, that one person should be able to talk to another person at a longer distance. And keeping that in mind, people have developed gradually the different types of transmission medium. And in fact, after this, soon after this period, there was a development of this electromagnetic waves. There was a development that was in the last, sometime in the last decade of the 19th century. The electromagnetic waves and all these things came into existence, due to which it was possible to do wireless communication, and even telephonic system also started using this wireless transmission from the beginning of the 20th century. Okay, so this is what we have talked about in the telephone system, the oldest telephone system. Okay, so now we will be in the next class, we will be switching over mostly to the electronic communication, which are still in use with lot of developments. Okay, we'll talk about it in the next class.
Excuse me, sir.
Bolo.
Sir, I have a doubt. So what is meant by crosstalk between adjacent cable pairs?
Crosstalk means suppose I am talking to another person and another person is talking to another person with in a parallel cable. Okay, as I have said that you will be having multiple cables bundled together. So you have one pair and one pair next to each other. So suppose I am talking from Delhi to Bombay to one person. Another person is also talking from Delhi to Mumbai in a parallel. That connection is just parallel to it and adjacent to it. So now, since there will be some means interference. See, when the signal electromagnetic wave is propagating, okay, it is not always because these cables are not that good. That is what actually coaxial cable can do, but not these cables. What will happen that there will be some electromagnetic wave which is propagating in one medium that will get radiated in its surrounding. Okay. Similarly, the other pair of cable, which is also adjacent to it, some of its signal will be radiated in its surrounding. So that signal will get added to this signal to some extent, and this signal will get added to the other signal. You are getting it? So
Sir, a single bundle of that combines multiple pairs of twisted cables that establishes one connection or multiple
multiple
connections.
connections. That is what I am saying. Suppose there are 10 people in Delhi wants to talk to 10 people in Mumbai, and I have to have 10 connections, isn't it? Okay. So 10 connections are required, and you have to have 10 lines. Okay. Now, generally, what you do, you don't, I can obviously, I can put one line here, another line at a longer distance from the other one. So 10 lines can be separated from each other, but that will be means, installing that will be very difficult. So what you do, you install only one single way, you dig one, say this for putting this cable underground, you will be digging one tunnel from Delhi to Mumbai. Okay, and you put all the 10 cables. Okay, they are bundled together and you put all the 10 cables in that tunnel. Okay, so they are adjacent to each other. So you are connecting 10 people from Delhi to 10 people in Mumbai through 10 different lines, but they are adjacent to each other. They are, in fact, they are bundled together. Okay, so whenever some signal is flowing through one pair of cable, there will be some signal radiating in its surrounding, and in the surrounding there is another cable. Okay, so this signal will get added to the signal which is flowing in that cable. Okay, so that signal will get distorted. Okay, and in fact you will be having some humming sound and all these things you will be hearing. In fact, if there is a silence period, you will be hearing the other person's voice also. Okay, so that is the crosstalk.
Okay, sir. Thank you, sir.
You're getting it, na? That whenever there are two channels, you can say these are two channels just next to each other, and since there is some leakage of signal from one channel to its surrounding, so this signal will get added to the signal flowing in the other channel. It is like that. So that is called crosstalk. Okay, so you'll be hearing some sound from the other person, which you are actually not your caller. Okay, this is not connected through the cable, but it is connected because of the in the surrounding air. In the surrounding air, the air surrounding that conductor, since there is some signal leakage, that will disturb, do the disturbance. Okay.
Okay, sir. Thank you, sir.
Oh, any more question? Okay. If you have no more question, then I think you can now leave the meeting. We'll meet on Monday. Okay.
Thank you, sir.
Okay. Thank you and bye.
Thank you, sir.
Okay. See you on Monday.